Good evening, dear students. How are you all? I hope my audio is clear. Yes or no? Yeah, good evening, Prashant. Okay, let's begin today's session in few minutes. Kindly wait and be ready with the yesterday's topic. Hello, students. Hello, hello. I hope my audio is clear. Yes or no? Can I get a quick overview of previous session in the chat box? You guys there?
Can you hear me? Yeah, thank you for your response. So, shall we start the session? Can you see the screen? Is my screen is visible? Yeah. Yeah, thank you. Yeah. Can you hear me? Is my voice is audible? Okay. So shall we start the session? Okay, nice. So in today's session, we are mainly focusing on two important ideas. Okay. So the first idea is how multiple AI agents work together instead of working alone. Okay. The second idea is how we check whether these AI agents are actually doing their job properly. So to understand this, think about teamwork in real life. When we work together, work gets done faster, but only if everyone is coordinated, right? If there is no coordination, even a team can fail, right? So AI systems face the exact same situation. Okay, so we will talk about collaboration and orchestration. So collaboration simply means agents helping each other and sharing work. Okay, so orchestration means managing these agents just like a manager in a company or a captain in a team, right? Without orchestration, agents might work randomly, repeat the same work, or even create problem for each other. We will also discuss evolution. Evolution just means checking performance. Okay, so think about exams or grades. Without them, you wouldn't know how well you are doing, right? In the same way, evolution matrix helps us understand whether an AI system is working correctly or failing. These ideas are very important in real companies where AI systems operate on a large scale and affect many users. So this is about this. Shall we go to the next slide? So now let's clearly understand what we want to achieve by the end of the session. Okay. So the goal is to memorize definitions or complicated terms is not important, right? So the real goal is to understand how AI systems actually works behind in a real life. First, we want to understand how multiple AI agents collaborate. This means how different AI systems talk to each other, share work, and move towards the common goal. Think about a relay race. One runner starts, passes the bottom, and another continues. If they don't coordinate properly, the race is lost. AI agents works in the same way. Okay. So next, we want to understand orchestration. So orchestration is like having a plan or a system that decides which agent should do which task and in what order. So without orchestration, agents might all try to do the same thing and ignore the important task. So this is a similar to a group project without a leader or a timetable. So finally, we want to analyze performance and reliability. So this simple means checking whether the AI is doing what it is supposed to do and whether it can be trusted. Just like you check your marks to understand your progress, the companies check AI performance to make sure systems are safe and useful. Got it? So this is our agenda. So let's move to the next concepts. So what is multi-agent system? Guys, is it okay? So may I know is I'm going fast or slow? Is my voice is audible? Yeah, thank you. So let's move to the next concept. So now let's understand what a multiple agent system really means. So without using any heavy words, okay? So a multiple agent system is simply a system where more than one AI agent exists and works together. Think about a restaurant, okay? So one person takes order, another cooks food, and another picks it, right? And someone else delivers. So each person has a role, and together that make a whole system work. In the same way, a multiple agent system has many AI agents, and each agent is responsible for specific task. So each agent is autonomously, which means it can make decisions on its own. It does not wait for a wait for us to tell it every small step. One agent may have a main goal, while another agent may have a smaller goal that supports the main one. Okay, so for example, in a shopping app, one agent handles product search. Okay, another handles payments, and another one handles delivering tracking. Okay, so this is how the multiple agents coordinates together and to work together and they complete a common task. So these agents interact with each other. Same times they cooperate to achieve a shared goal. So that's what a common goal. And sometimes they compete if their goal are different. This interaction is what makes the system powerful. So instead of one AI trying to do everything, work is divided. This makes the system faster, more flexible, and easier to scale as we it grow. Got it? So in wait a minute. So in multiple agents, what is the thing happening here? So the multiple agents will work together and coordinate with each other and complete a entire task by dividing the task into subtasks. Okay, guys, if you have any doubts, please mention in the Q&A so that I can clarify that. So if you don't have any doubts, please give a thumbs up symbol so that we can move to the next topic, right? Shall we move to the next topic? Or if you have any doubts, please mention in the Q&A. Okay. Guys, if you don't have any doubts, please let me know with the thumbs up symbol so that we can move to the next topic. Or else, if you have any doubts, please mention in the Q&A. Guys, I want reply from everyone. So I'm getting a limited replies. So what about others? Please be active in the session, okay? If you have any doubts, please mention in the Q&A. If you don't have any doubts, please let me know with the thumbs up symbol so that we can move to the next topic. Okay. Guys, attendance sheet will be shared at the end of the session. Okay. Don't worry about attendance sheet. Okay. So we will share the attendance sheet. So let's discuss why multiple agent collaboration is needed. So if you have any answer, please let me know in the Q&A. If you don't have any idea, it's fine. So we can start from scratch. So now let's talk about why we need multiple agent collaboration in the first place. Okay. So in real life, problems are rarely simple. Most problems are big, complex, and spread across different areas. Imagine managing a large shopping website like Amazon. One system has to track inventory, another has to handle orders, and one more manages delivery, and one more deals with the customer support. So if only one AI tries to do everything, it would become slow, confused, and inefficient, right? So this is why multiple agent collaboration is needed. When multiple agents work together, each agent focus on a small part of the problem. This makes the system faster and more efficient. It also allows work to happen in parallel. For example, while one agent is checking product availability, another agent can already start planning delivery. This saves time. So multiple agents systems are also more robust. If one agent fails, the entire system doesn't stop. So other agents can continue working, right? So this is very useful in real world systems like supply chain management or smart city traffic controls. So we have discussed these examples in the previous sessions, right? So about traffic controls, right? So where things are constantly changing and systems need to respond quickly. So collaboration helps AI systems scale smoothly as they grow bigger and more complex. So that's why we need collaboration to handle the real world problems effectively. Okay. So do you have any doubts in this topic? So if you have any doubts, please let me know in the Q&A. So I hope everyone have understood that why we need collaboration between the agents, right? So without a good collaboration, we cannot solve the problems easily, right? So we have to maintain a planning order for agents to complete the work. So that's why we need collaboration between each and every agent. Understood? Please let me know in the Q&A if you are clear with the collaboration concept. Please mention clear. If you have any doubts, please let me know in the Q&A that I have a particular issue. Okay. So I want response from everyone. So please be active in the session. So try to give the replies. Okay. Guys, if you have any doubts, please let me know in the Q&A. So if you don't have any doubts, please mention clear. Okay. So that we can move with the another concept. Okay. So I got only 3 responses. Please be active in the session and give the replies. So if you have understood the topic, please give a thumbs up symbol. If you have not understood any topic of today's, please let me know in the Q&A so that I can explain once again. So if you have doubt, okay. Okay, shall we move to the next topic? So if we want to move to the next topic, please mention next in the Q&A so that we can move to the next topic. Okay. So if you have any doubts, please mention it, or else please type next so that we can move to the next slide. Okay. I want at least 10 so that we can move to the next topic. Okay. I just got a 5 replies as the next. So what about others? If you have any doubts, please mention it in the Q&A. I just got like around 8. I can see total strength is 193, right? So please try to be active in the session. And if you have any doubts, please mention it. If you don't have any doubts, please try to reply so that we can continue with the other topics. Okay. So today is we are having a very important concepts. So how this multi-agent systems works and how we can check whether they are performing. So this is a very important session, right? Guys, we will share the attendance at the end of the session. Okay. So if you have any doubts regarding attendance sheet, so please try to ask at the end of the session. Okay. Okay. Shall we move to the next slide? So this is our next topic is about forms of agent collaboration. Okay. So now we have clarity about what is collaboration, right? So now we will detailedly explain what are the forms of collaborations. So shall we start? If you have any queries, please mention it. If you don't have any queries, please give a thumbs up symbol so that we can go with the next topic, the forms of collaborations. Okay. So now let's understand the different ways in which AI agents can work together. So just like how we communicate with that each other. So in the same way, the agents will work, right? So just like us, don't always work in the same way. So AI agents also collaborate in different styles. Sometimes agents cooperate with each other, meaning they all work toward the same goal. Okay, so think about a football team. So every player wants to win the match. So they pass the ball, supports each other, and plays as a team, right? So sometimes agents compete with each other. This is similar to student competing for higher marks or companies competing for customers. So each agent tries to do better for itself but still follows the overall rules of the system. So competition can actually improve performance because agents try harder to make better decisions. So in many real world systems, both cooperation and competition happen together. So this is called hybrid collaboration. For example, sellers on an online shopping platform compete with each other to sell products, but they also cooperate with the platform by following its rules. So understanding these different collaboration styles helps us design AI systems that behave correctly in a real situations. Okay, so now dif- we got the different forms of agent collaborations, right? So one is cooperative collaboration and another one is competitive collaboration and one more is hybrid. So in that hybrid we have both the combination of collaborations. So one is cooperative and one is competitive, right? So we have these three types of collaborations in agents. Okay, got it? So may I know how many types of uh, different types of collaborations are happening between agents in the chat box? Sorry, in the Q&A. I want reply from everyone. This is a very important topic. So because the communication plays a main role between in the agents to work together and to complete a task effectively, right? So I want replies from everyone. So what are the different, so how many different types of collaborations are happening in the agents? I got only one reply. So may I know about others? So do you have any doubts? Please let me know in the Q&A. So if you don't have any doubts, please give a answer for that. Okay. So how many types of collaborations are there? This is my question. So can you see my question? So if you have any doubts, please let me know. So if you know the answer, please mention in the Q&A. So So Pranjali mentioned two. So actually we have three types of collaborations. So one is comparative and competitive and hybrid. So in hybrid we includes both cooperative and competitive, right? Guys, I want replies from everyone. So if you have any doubts, please mention in the Q&A. I hope everyone understood that we have three types of collaborations, right? So I think everyone understood, right? How many types of collaborations are there? So, so can I get a symbol of super so that in that three fingers are up, right? So you want this symbol from your side? Yeah, exactly that symbol. So please make sure that everyone is sending that symbol so that everyone can understand that we have three types of collaborations. Yeah. So I think everyone understood, right? Shall we move to the next topic? So someone is sending that code magnifying lens. May I know what it means? So okay, guys, if I want to move to the next slide, please make sure that you are sending the super symbol as a reply so that we can move to the next slide. Okay. Yeah. Okay. Thank you guys for your response. So I want everyone to be active in the session. Okay. So if you are facing any issue, for example, like understanding the content, or if you have any other doubts, please mention in the Q&A. So don't be feel free. Okay. Okay. Let's move to the next topic. Okay. What is our next topic is so agent orchestration definition. Okay. We will learn about orchestration. Okay. If you have any idea about orchestration, please mention in the Q&A. So, okay. Okay. So now let's talk about orchestration, which is a very important idea when many agents are involved. So orchestration simply means coordination, right? So orchestration means coordination. So it is about making sure all the agents working together in an organized way instead of acting randomly. So think about a school function. There are students handling decorations, other managing sounds, some handling registrations, and some coordinating the guests. Okay, if everyone does whatever they want without coordinating, the event will fail, right? So orchestration makes sure everything runs smoothly. So in AI systems, orchestration decides which agent should do which task, in what order tasks should happen, and how information should flow between agents. So without orchestration, agent might repeat the same work or miss important steps. So this can create confusion and waste resources, right? We can think of orchestration as a conductor in an orchestra. Each musician plays their own instrument, but the conductor ensures they play together at the right time, right? So similarly, orchestration ensures that AI agents work together as a system, not as a isolated pieces. This makes the system efficient, reliable, and easier to control. So that's why the orchestration in agents are very important. Got it? Guys, I want to know how many of you understood orchestration agents. Please mention in the Q&A. If you have any doubts regarding that, please mention in the Q&A. Okay. So if you don't have any doubts, please mention as a clear. Guys, I want replies from everyone. I can see our total strength is 226. So I want know everyone to answer this. Okay. Guys, if you have any doubts, please mention in the Q&A. So if you're asking to me to explain once again, okay, I will explain it. Okay, in short, no worries. So if anyone is having any doubts, please mention in the Q&A. If you don't have any doubts, please mention as clear. Okay. Okay, I will explain once again. Okay, in a simple way. So orchestration means coordination. Okay, when many AI agents are working together, orchestration makes sure they don't act randomly. It decides who does what, in what order, and how agents share information. So, like, think of a school event. Some students manage decorations, some handle sounds, DJ, you can say. So, others do registration. If everyone works without coordination, the event become fails. So orchestration is what keeps everything organized and running smoothly. So everyone make coordination with each other and make the event successful. So in the same way, AI orchestration ensures agents work together as one system, not separately. Okay, so it avoids repeated work. So it won't miss the important steps and it won't be confused while doing the task. So you can think of it like a conductor leading an orchestra, making sure all musicians play together at the right time so that they can compose good music, right? Got it? Arithya, you got the concept? So if you have any doubts, please mention. Okay, got it right. So guys, I want everyone to reply. So if you have any doubts, please mention in the Q&A. If you don't have any doubts, please mention clear so that we can move to the next topic. Okay. I can see very few students are active in the session, and what about others? If you have any doubts, please mention it. If you don't have any doubts, please be active in the session, and if I ask anything, please try to answer. Okay. You can share different symbols as well. Okay. So not only thumbs up, you can share other symbols as too. Okay. Guys, if you are thinking about attendance, I have already shared, right? So we will discuss at the end of the session about attendance, okay? So we will share the attendance sheet with you, okay? No worries about attendance, okay? Okay, shall we move to the next topic? Yeah, sure. Okay, let's move to the next topic. So what is our next topic is about? Centralized orchestration. So we have discussed about orchestration. So now we are discussing about centralized orchestration. Okay. So now let's understand one common way of orchestration called centralized orchestration. In this approach, there is a one central controller that manages everything. So this central controller decides which agent should do which task and when it should do. Okay, so the agents then complete their task and report the results back to the central controller. Think about a classroom. The teacher gives instructions, students follows them and then report their work, right? That is a centralized system. The biggest advantage of centralized orchestration is that it is easy to control and monitor. Since there is a one main controller, it is simple to track what each agent is doing. If something goes wrong, it is easier to identify and to fix the problem. Okay. So, however, centralized orchestration also has a big limitations. If the central control fails, the whole system can stop working, right? So this is called single point of failure. So if the central control fails, the whole system can stop, right? So this is called the issue of single point failure. So while centralized orchestration works well for small, and it can be risky for very large systems where reliability is critical. So we can use centralized orchestration for simple systems. So if we are dealing with the big systems, it is risky. Okay. Yes, Prasad, right. That's what centralized orchestration means. So one main controller manages the ev- each and every other agents. Guys, if you have any doubts regarding centralized orchestration, please mention in the Q&A. Okay. So I think it is very simple to understand centralized orchestration, right? So we have a one centralized controller. How a classroom is maintained by a teacher. So in the same way, the different agents will be maintained by a centralized agent. So that's called centralized orchestration system. Okay. Got it? If it is clear, please mention clear. If you have any doubts, please mention your doubt in the Q&A. Okay. Got it right? So we have its simple in simple words here. So central control assigns task. How a teacher assigns task to students, and agents report results back. How a student completes a task, then he is going to report the teacher, right? So I have completed this task, right? So in the same way, agents will report back to the central controller. So the advantages are simple to control and easy to monitor. So as we have centralized controller, so it is easy to control and easy to monitor. The limitations is single point of failure. Like if central controller fails, the entire system will be stopped. So that's why we have a limitation called single point of failure. Got it? Guys, if you have any doubts, please mention in the Q&A. If you don't have any doubts, please mention clear. Yeah, we're going to discuss about multi-central controllers, okay, in the next. Guys, if you have any doubts, please mention it. If you don't have any doubts, please mention clear. I want replies from everyone. If it is hard to type, please give a reply size emojis. Guys, shall we move to the next concept? So, as someone is mentioned that is there any chance of multiple central controllers. Yeah, we will discuss about this in the next slide. Okay. Guys, if you have any doubts, please mention in the Q&A. If you don't have any doubts, please mention clear so that we can move to the next topic. Okay. Yeah, we are discussing in very simple and easy way to understand, right? That's why you guys are not finding any difficulty to understand the concepts, right? So if anyone finds it difficult, please mention in the Q&A. Okay? So I hope everyone is able to understand the concepts, right? Okay, shall we move to the next topic? If yes, please give a thumbs up symbol so that we can move to the next topic. So how we can handle this single point failure, we can discuss in the next slide. Okay. Okay. So our next topic is about decentralized orchestration. So this is the another way of coordinating agents. So we call it as a centralized orchestration. So in this approach, there is no single boss, or we can say central controller, right? So instead, all the agents talk to each other directly and decides what to do together. So this is a difference between centralized controller and decentralized orchestration, right? So we have a we don't have any centralized controller here. So instead of that, the different agents talk to each other directly and decides what to do together. So think about a group of friends planning a trip. There is no leader giving orders. Okay. So everyone shares idea and discuss plans and agrees one on what they want to do, right? So that is a centralized system. Got it? So what is the centralized controller? You got right? So the biggest advantage of decentralized orchestration is that it is very strong and flexible. If one agent stops working, the other agents can still continue. The entire system doesn't not fail just because of one part fails. So this makes centralized systems more flexible, especially for large scale applications. So if one agent fails, so other can coordinate and complete that work, right? So however, decentralized systems are harder to design since there is no centralized controller. So agents must communicate clearly and avoid conflicts, right? So sometimes agents might disagree or coordination might take more time, even though it is complex. Decentralized orchestration is very useful in systems that need high reliability and scalability, such as large networks or distributed platforms. Right? So, decentralized orchestration is, in simple, we can say as a group of friends planning for a trip. So they share their idea and plans, right? So they will agree upon each other. And sometimes they will disagree, right? So in that case, the what we say discussion goes on, right? So that's a drawback in the centralized systems also. Got it? If you have understood what is decentralized orchestration, please mention clear. If you have any doubts, please mention it. So if you want me to explain once again, it is okay. I will explain once again. Okay. If you are clear, please mention clear. I hope everyone got what is decentralized orchestration, right? Guys, I need replies from everyone. Guys, I want replies from everyone. If you have not understood, please mention the uh, problem you are facing. So if you don't have any doubts, please mention it is clear, or else you can say the emoji so that we can continue with the other topics. Okay. I want replies from everyone. Okay, shall we move to the next concept? Please mention next in the Q&A so that we can move to the next topic. Okay. I hope this session is very interactive, right? If not, please mention uh, so that we can make it very interactive. Okay. So if you want more examples, please let me know so that we can discuss more and more examples so that the concepts will be very clear, right? Yeah, we will discuss about projects also in upcoming sessions. So after once we complete with the training, so we will go with the practical projects. Okay. Okay, let's move to the next topic. The topic name is hybrid orchestration models. So now, as of now, we have discussed about centralized orchestration and decentralized orchestration. So now we will discuss about combination of both. Okay. So now let's talk about a MIDI approach called hybrid orchestration. So as the name suggests, hybrid orchestration combines ideas from both centralized and decentralized systems, right? So hybrid means which is a combination of centralized and decentralized systems. This means there is some level of centralized planning, but agents also have the freedom to make their own decisions. Okay. Think about a company. There is a management team that sets goals and rules, right? But individual employees still decide how to complete their daily work. That is a hybrid model. Okay, so in hybrid orchestration, the centralized part may decide the overall goal or strategy, while individual agents handle specific tasks and adjust based on the conditions. Okay, so this gives a good balance between control and flexibility. Okay, the system is not too rigid like a fully centralized system and not too feel like fully decentralized one. So many real world enterprises AI systems use hybrid orchestration because it works well at large scale. It allows companies to maintain oversight and safety while still giving agents enough freedom to respond quickly to changes. Right? So hybrid orchestration is often most practical choice for complex AI systems so that the system works well and good. So by using both the combination of centralized and decentralized orchestration. Got it? Shall we move to the next topic or do you want break for 10 minutes? So if you want break, please mention break so that we can have a break for 10 minutes. So if you guys want me to continue, so I will continue. If you want break, please mention break. Okay. No, no, we can't give 15 minutes break. Okay, we don't have that much time, so I can give uh, like 10 minutes of break. Okay. So how many wants break? I think no one wants break, right? That's why I can't see any break message in the Q&A. If you want to break, please mention break in the Q&A so that we can have a break, or else we can continue the next topic. Okay. Okay, guys. I will give a break from night 7:13 to 7 7:23. We are having break. Okay. So have a break and come with a fresh minds. Okay. And guys, more important thing is don't leave the session. Okay. Have a break. Okay, guys. I hope everyone enjoyed your break, right? So let's go with the other topics. Okay, guys, can I get the thumbs up symbols? I hope everyone didn't got any response from your side. Please be active. Come back to the session. So let's talk about the next topic is allocation in multi-agent systems. Okay, so now let's talk about this concept. So task allocation in multi-agent systems. So what it means actually. So allocation simply means deciding which agent should do which task, right? Yes or no? So task allocation means so we are deciding which agent should do which task. Okay. So this is very similar to how work is divided in real life. So imagine a group assignment. So we don't give the same task to everyone, right? So instead, we decide based on who is good at what, and based on that, we will divide the task to the team members, right? So AI systems do the same thing but automatically. Okay. So in a multi-agent system, each agent has different abilities. Okay. So some agents might be faster, some might be better at analysis, and some might have access to specific tools. So tasks at this difference and assigns tasks in a smarter way. So it also considers whether an agent is available and how important the task is. So good task allocation makes the system efficient, work gets done faster and with fewer mistakes. So poor task allocation can overload one agent while other is ideal. So that's what so so good task allocation makes difference. So that's why task allocation is a very important part of designing multi-agent systems. Okay, got it? So let's move to the next topic. So it is very simple, right? So what is task allocation? So how a teacher allocates project based on the student's ability. So in the same way, task allocation works. So next move to the next topic. So agent communication mechanisms. So now we will discuss about this topic. So now let's talk about how AI agents communicate with each other. And communication is very extremely important when many agents are working together. Think about a group of friends planning to a trip. So if no one talks to each other, everyone will do same thing different and the plan will fail. So in the same way, AI agents need communication to coordinate their actions between each other. So agents can communicate in different ways. So one common way is by sending messages. So this is like sending a text message to tell another agent that what has been done or what need to be done next. So another way is through shared memory or shared state. So we have two different types of uh, coordination or communication. So one is sending the messages, or one is another one is shared memory. Okay, so this is like using a shared Google document where everyone can see updates in real time. So if you have used Google Docs, so you might be familiar with this. Okay, so when one agent updates something, other can read it and act accordingly. So agents can also communicate through events. For example, when something important happens, an event is triggered and other agent react to it. So without communication, agents would work blindly. So communication helps agents stay aligned, avoid repeating the work, and move towards the same goal smoothly. So that's why communication is key part of any multi-agent systems. Right? Got it? Guys, we will share the attendance sheet. Don't worry about that. So at the end of the session, we will share it. Okay. So are you clear with the topic? So agent communication mechanism. So we have three types of communication mechanisms. One is message based, and one is another one is shared memory, and last one is event based communication. So for message sending, we can have a like example like WhatsApp message sending. So if we are planning for a trip, so friends will message, right? So what we need to do and what actions we need to take, right? So like shared memory is like Google Docs. So if one person is editing, so others can see the uh, updates, right? So in event-based communication, if something is happened, so the next action should be taken by another agent. So in this way, the agents will communicate with each other. Okay, got it? So may I know how many types of agent communication mechanisms are there? Please mention the answer in the Q&A. So my question is, how many types of communication mechanisms are there? Please mention your answer in the Q&A. Guys, I want replies from everyone. So it is very clear that so how many types of communication mechanisms are there in the agents, right? Guys, I want replies from everyone. I can see 260 students are there. So I got only 2 or 3 replies. What about others? If you are like having any confusion, please let me know in the Q&A. If you're clear, please mention the answer. Okay, shall we move to the next topic? So our next topic is coordination strategies. Okay. So now let's talk about how agents actually coordinate their actions when working together. So coordination strategies are simple, different way of agents communicate with each other. So like Simply, the different ways agents decides who leads, who follows, and how decisions are made as a group. Think about how you work in real life. Sometimes one person takes the lead, and sometimes everyone decide decisions were discussed, right? And sometimes talks are negotiated. So one common approach is the leader follower style. Okay, so this is like a captain decides the plan and others follows it. It works well when quick decisions are needed. So another approach is negotiation, where agents discuss and agree on who should do which task. So we have two types of coordination. One is leader and follower style, and another one is negotiation. So where agents discuss with each other and which task which agent should do. So like that communication will happen. So this is similar to students dividing work among themselves, right? So there is also consensus based approach where agents keep discussing until everyone agrees. So this is slower, but it helps avoid conflicts. So each coordination strategy has its own uses. The right choice depends on how complex the system is and how fast decisions need to be made. So good coordination helps agent avoid confusion, reduce conflicts, and work smoothly towards the same goal. Got it? So we have three types of coordination strategies. One is leader and follower model, and another one is contract net protocol, and last one is consensus based coordination. So we have these three types of coordination strategies. Okay, got it? Let's move to the next topic. So now let's talk about challenges in multi-agent collaboration. Guys, do you have any doubts till now? If you have any doubts, please mention in the Q&A, okay? If you don't have any doubts, please mention clear or give a thumbs up symbol so that we can move with the other concepts, okay? Okay, guys, next move with the next topics. So now let's talk about the challenges that come with multi-agent collaboration, okay? So when many agents work together, things are not always smooth, right? So one common challenge is conflicting goals. So this means different agents may want different outcomes. For example, in an online shopping system, one agent may want to show cheaper products to users, while another agent may want to promote premium products. Okay, so if these goals are not handled properly, the system can behave in confusion way, right? So one agent is providing the cheaper products and another one is showing the premium products, right? So another challenge is communication overhead. When too many agents keep talking to each other, it can slow down the system, right? So think about a WhatsApp group where everyone sends messages at the same time. So important messages could get lost, right? And confusion increases. So AI systems can face the same problem if communication is not well managed, right? So synchronization is also a challenge. So agents need to act the right time and in the right order. If one agent moves too faster or too slow, the whole system can get out of synchronization. So finally, trust and reliability are important. So agents need to trust and information they receive from other agents. If one agent gives wrong data, others may also make wrong decisions, right? So these challenges shows why designing multi-agent systems need careful planning. Got it? So shall we move to the next slide? So we have four types of challenges in multi-agent collaboration, right? So what are those four? So conflicting goals, communication overhead, synchronization issue, trust and reliability, right? So conflicting goals means two models are competing with each other for their goals, and the main task is stopped. Communication overhead means multiple agents discussing too long and making decisions. That's called communication overhead. So taking more time to decide what to do. Synchronization issue means so which agent what task it has to do. So in when it has to do. So that is called synchronization issues. Trust and reliability means so the agent has to provide correct information so that they work smoothly. Okay. Okay, let's next move to the next topic. So what is our next topic is so why evolution matters in agentic AI. So this is a very important concept, right? So we'll talk about this. Do you guys have having any doubts? If not, please mention clear. I hope by the what evolution all of you got the idea, right? So what is mean by evolution? So like how the agentic AI system works and how it performs. So this will be calculated in the evolution matter in evolution, right? So now let's understand why evolution is so important in agentic AI systems. Okay. So when AI agents are working on their own without our checking every small step, so it becomes very important to regularly check how well they are performing, right? So we don't interact uh, every time, right? So that's why the evolution matrix is very important to check their performance. So imagine a self-driving car. So we won't want to use it without testing and monitoring it continuously. The same idea applies to AI agents, right? So agents act autonomously, which means they make decisions on their own. So if one agent makes a mistake, that mistake can quickly affect other agents and spread through the system. So, for example, if one agent is in a recommendation system starts giving wrong suggestions, so many users get affected at the same time. That's why failures in AI system can grow very fast. So continuous evolution helps us catch problems early. It helps us understand whether the AI is behaving safely, effectively, and correctly. So evolution is like regular health checkups for AI systems. So without evolution, we may not even realize that something is wrong until the damage is already done. So this is why evolution is a critical part of building trustworthy and reliable agentic AI systems. right? Got it? Let's move to the next slide. Or if you have any doubts, please let me know in the Q&A. Don't have any doubts, we can move with the other topics, okay? Shall we move to the next topic? So now let's talk about how we actually evaluate agentic AI systems in a simple way, okay? So when we say evolution, we are basically asking one question, right? So is the AI doing its job properly or not, right? So to answer this type of question, we look at a few important aspects of how the agent behaves. So these aspects help us understand the overall performance of the system, right? So first, we want to see whether the agent is completing the task it was given. If an AI agent is assigned a job but keeps failing to finish it, then the system is not useful, right? So the next we look at accuracy. If it is working well, and then we will go for the accuracy. So this means checking whether the agent's decisions and outputs are correct. So, for example, if an AI is classifying issues or answering questions, we need to know if those answers are right or wrong. Right? So, efficiency is another important aspect. This is about how much time and resources the agent uses. So, an agent that gives the right answers but takes too much time to process. So, finally, we look at reliability. So, this means checking whether the agent behaves consistently and perform well even when condition changes. So, together these evolution dimensions helps us adjust whether an agentic AI system can be trusted in real world use. Okay, got it. So to evaluate an agentic AI systems, we will have four tasks. Okay, so task completion. So whether the agentic AI is completing the task or not, and accuracy, how well the agentic AI system works. Is it giving correct answers or not? Efficiency, how well the resources are being used by agentic AI. Reliability, can it be used for complex uh, works or not? Got it? Shall we move to the next slide? So, 1 minute. So, our next is task completion matrix. So, we will learn about this. Okay. So, now let's learn about task completion in a very simple way. Okay. So, task completion is about checking whether the AI agent actually finishing the job or not. So think about ordering food online. If you place an order and the food never arrives, then it doesn't matter how good the app looks, right? So the task is not completed. In the same way, an AI agent is useful only if it can complete its assigned task properly. So, for example, imagine an AI agent working in a customer support. Okay, so its job might be resolve users problem, right? So task completion checks whether the problem was actually solved or not. The agent keeps giving replies but never fixes the issue, then it has failed its task, right? So another example could be an AI agent assigned to process payments. If the payment doesn't not go through, the task is incompleted. So in that case, we will get a notification of processing, right? Payment is processing. So that is one of the example. So the task completion is also includes working within limits. So sometimes the task must be finished within a certain time or under certain conditions. Okay, so completing the task correctly and within this limits shows that agent is performing well. So this matrix helps us clearly see whether AI is delivering real value or just producing activity without results. Okay. I hope task completion you have understood, right? It is very simple whether the agent is completing that actual task or not, right? Okay, shall we move to the next slide? Okay, let's move to the next slide. So we have accuracy matrix. Do you have any doubts, guys? Do you have any doubts? Please mention in the Q&A. Okay, now let's talk about accuracy. Okay, so which is another very important way to evaluate AI agents. So accuracy is all about correctness. Got it? The accuracy means correctness. How well the agent can answer. So it checks whether the decisions or outputs given by the AI are actually right. Think about exams. So we may answer all questions quickly, but if the most answers are wrong, your performance is not good, right? So in the same way, an AI agent must give correct results, not just fast results, right? So for example, imagine an AI agent that classifies customer complaints. If a customer has a payment issue and the AI marks it as a delivery issue, that is an accuracy problem. So even though the agent responded, the response was incorrect. The accuracy helps us understand whether the AI truly understands the problem and gives the right solution for the problem. So the accuracy is especially important in sensitive areas like healthcare, finance, and education and banking. So a small mistakes can have serious consequences in these fields, right? So that's why AI systems are carefully tested or to make sure the decisions are logically correct and based on correct information. So high accuracy builds trust. When users see the AI gives correct answers consistently, they feel more confident about using the system, right? Okay, let's move to the next slide. So So we're done with the accuracy matrix, right? So let's move to the next topic. So efficiency matrix. So let's understand efficiency, okay? So which is about how smartly an AI agent uses time and resources. So efficiency mainly de- depends on time and resources. How well the AI agent uses the time and resources. Okay. So efficiency does not mean just finishing a task. It means finishing the task quickly and without wasting too much power, money, or efforts. Right? So think about two students who both finish an assessment. So one finishes it in 2 hours and another one finishes it in 2 days. So both complete the task, but the first student was more efficient, right? So because he is finishing the work within 2 hours, so that's why he is more efficient. So in AI systems, efficiency is very important because resources cost money, right? So we are using resources, that means we are spending too much of money, right? So for example, AI systems use computing power. So to run the AI agents, we need computational power, right? So, and we also need internet calls and storage. So if one AI agent takes too long or uses too many resources to complete a simple task, it becomes expensive to run at a large scale, right? So companies care a lot about this. So efficiency also affects users' experience. If an AI assistant takes too long to respond, users get frustrated, right? So even if the answer is correct, slow performance can still be a problem. So if efficient AI agent save time, reduces cost, and provide the better experience. So that's why efficiency is a key matrix when evaluating agentic AI systems. Okay, I hope everyone understood about efficiency matrix, right? So efficiency is nothing but how well the AI agent is using the resources and time to perform the task. Okay, so let's move to the next topic. So reliability matrix. I hope everyone is following, right? So if you have any queries, please let me know. Now let's talk about reliability matrix. Okay, so which is about trust and consistency. So reliability means the AI agent behaves properly again and again. So not just once. Okay, so think about your internet connection. If it works well one day and fails the next day without any reason, so you stop trusting it, right? So in the same way, an AI agent must work consistently for us to trust it, right? So reliability checks whether the agent can handle different situations. Sometimes conditions changes. So data may be noisy, inputs might be unclear, or system might slow down. So a reliability AI agent should still perform reasonably well in these situations. So even if something goes wrong, it should recover instead of completely failing. So one way to understand reliability is failure rate. So if the agent fails very often, it is not reliable. So another important idea is recovery capability. This means when something goes wrong, can the agent fix itself or continues working? So the reliability AI agents doesn't panic when errors happens. Okay, so they detect the problem, recovers, and moves forward. So that's what reliability really means. So this is very important in real world situation, right? Where perfection is impossible, but consistency is required. Okay, got it. I hope everyone got about the reliability matrix, right? So let's move to the next slide. Guys, if you have any doubts, please mention in the Q&A. So I think we are going in a smoother way, right? If you are feeling I'm going fast, please let me know in the Q&A so that I can slow down. Or if I'm going very slow, please mention it so we can adjust accordingly. Okay. So now let's move to the next slide. Yeah. So we came to the final slide. Okay. So now let's talk about what we have discussed till now from the beginning. Okay. So now let's wrap everything up and connect all the ideas we have discussed till now. Okay. So multiple agent systems helps us. So guys, this is a very important slide. Okay. Don't skip it. So if you are not active while we are discussing any other topics, so we will cover entire topics in this slide. Okay. So multiple agent systems helps us build AI that can scale and handle complex problems. Okay, instead of one AI doing everything, multiple agents share the work. So this makes system faster, more flexible, and easier to grow. So, but simply having many agents is not enough. So they need to work together properly. Got it? So why we need multiple agents? Because to make the system faster and flexible to easy to grow. So that's why we need multiple agents systems. So having multiple agents is not a good enough. So having good communication between them is more important, right? So to uh, complete the work smoother, we need good communications also. So that's why we are having topic called orchestration, right? So orchestration ensures agent coordinate, communicate, and follow a clear instructions, right? So whether the system is centralized or decentralized or hybrid, the goal is always the same. Make sure agents work together smoothly instead of creating confusion, right? So evolution is equally important. AI systems act autonomously, right? So we must continuously check how well they are performing. So matrices like task completion, accuracy, efficiency, and reliability helps us to understand whether the system is actually useful and trustworthy. These matrices are not just technical ideas, they directly affect real users and real businesses. Right? So the biggest takeaway is this. The AI does not need to be perfect. It needs to be reliable, measurable, and well coordinated. If you understand these concepts, you are already thinking like a AI system designer. Okay, so not just a AI user. Got it? This is the takeaway of this session. So guys, if you have any doubts, please mention in the Q&A. Okay. Guys, if you have any doubts, please mention in the Q&A. So we are covered all the topics of today's. Okay. So guys, we are having quiz. Don't leave the session, okay? So we will have a very interacting quiz. Okay, we will conduct that quiz. So please guys participate in these quizzes, okay? So these are uh, given marks for these quizzes, okay? So this will affect your certificate, right? So we will have a separate marks for quizzes also. So that's why we are saying that these are very important and everyone should attend the quizzes. Okay. So if someone left the session, please let them know that the quiz is conducted right now. Okay. So I will share the quiz link. Be active and participate in the quiz. Okay. Guys, I am sharing the quiz. So we participate in the quiz. Okay. The quiz. I hope quiz is visible to you, right? So please join in the quiz. Don't leave the session without attending the quiz, okay? So please participate in the quiz. Guys, please join in the quiz. Uh, guys, please join faster, okay? So we are left with very few minutes. So join the quiz. We will start the quiz as soon as possible, okay? Guys, please join the quiz as soon as possible, okay? Guys, please hurry up. Please join in the quiz as soon as possible. If you are facing any issue with the quiz, please let me know in the Q&A. Okay? Don't leave the session without attending the quiz, okay? Please participate in the quiz. Within 2 minutes, I'm going to start the quiz, okay? So, meanwhile, please, you are not joined in the quiz, please join in the quiz. Yeah, we will conduct quiz every day, okay? Guys, the quiz is going to start within 1 minute. Please, if you are not joined, please join quick, okay? Okay, guys, I'm starting the quiz. Yeah. Tomorrow session, okay? So thank you.